This is the real Tom Rose, and this is a super complicated question. This is just, it's on the ridiculous scale. So they give you an equation. It's got x's and k's in it. And they want you to solve for k somehow. Miracle. And the only clue that they give you is that this thing has equal roots. When they say it's equal roots, what they're saying is if you factor it into two binomials like this, where you have an x term at the front of both plus some numbered term, right? They're saying if you build that form, that these two things will be equal to one another, right? They're the same. The left one is the same as the right one. That's their constraint. So we can use that constraint to FOIL this out and then back solve for k. So when you FOIL this, these two binomials, the two numbered terms, when they multiply by one another, so let's call the number term for now, let's call it question mark, say. If you have question mark squared, that must equal 9k. So I'm going to do is take the square root of both sides, and what that'll yield is that the question mark, the unknown term, right? It's not a variable or a number. That's why I'm putting a question mark. It's sort of it's a term. That is equal to 3 root k. So if I plug that in, we're saying this must be 3 root k. And the sign is determined by just the sign of the thing. We're putting in a positive 3 root k. Okay, so this must be our roots. This is our binomial, right? So we just factored the equation that we were given, and it must be there. It must be that. Now what we can do is we can actually do, we can FOIL this out, the thing that we were given, and compare it with the equation we were given, and we should be able to solve for k. So let's do that. So I'm going to FOIL this out. So we'll get x squared plus 2 times 3 root k times x. Yep. Plus 9k. That must equal x squared plus 2 times k plus 2x plus 9k. And there's a bunch of things that are similar in here, and so let's go ahead and cross those out. So the x squared terms we can cancel, the 9k we can cancel, and you can cancel the 2's even on here, and the x's. And what it shows is that 3 root k must equal k plus 2. So we need to solve this, which means you got to square both sides. So this is starting to get a little hairy. But I'm pretty confident we're going in the right direction, so let's keep doing it. Let's square both sides, and what you'll end up with is 9k equals... Actually, what we're going to end up with here is a quadratic. K squared plus 2k plus 4k plus 4. Now, you need to actually solve this for... We could solve this for k and get the answer, but I think I'm seeing a faster way, which is now that I've got this relationship for k, I'm going to try back solving it. Right? So I'm going to kind of cheat a little bit. I'm going to go to the answer choices and plug them in and see what works, because now I know what numbers might make this work. So instead of solving it, I'm going to kind of just plug in for k. So for example, 4 is in every single one. So 4 must work. Actually, no, that's their negative 4s. But let's try 4. So if I plug in a 4 for k in here, does it work? If I get 3 root 4, does that equal 4 plus 2? So that is 6 equals 6? Yes. So 4 works. So 4 must be in the answer, so we can get rid of that one. So now we need to figure out what other one of these works. So let's try them. I'm just going to try them in order. Let's try 1. If we plug in a 1, remember these squareds don't exist. You can simplify those away. Let's plug in 3 times 1 equals 1 plus 2. 3 equals 3. That works. So 1 must be the answer. So that it must be B.